My name is Nielsen, and this is the video abstract for the paper A Covering System with Minimum Modulus 40. A covering system is simply a finite set of congruence classes for which all the moduli are distinct and for which every integer belongs to one of those congruence classes. The simplest, non-trivial example can be viewed as follows. Consider the integers as points along a line as pictured. We first take the congruence class 0 mod 2. Next we take the class 0 mod 3. There is some overlap between these two classes, which is not pictured. Similarly, we take 1 mod 4, 1 mod 6, and finally 11 mod 12. The least common multiple of the moduli is 12, hence the pattern pictured above repeats every 12 integers. This means that every point is covered. Covering systems were initially introduced by Paul Erdős and have subsequently been applied to questions about irreducibility of polynomials and compositeness tests for integers. There are two main open conjectures about covering systems. The first is called the Erdős Selfridge conjecture, and it asks whether there is a covering system for which all the moduli are odd. The second conjecture, which is the focus of my paper, is called the minimum modulus problem. It asks, basically, what is the maximum possible minimum modulus? The previous record was 25 as found by Gibson. My paper establishes that there is a covering system with minimum modulus 40. There are about 10 to the 50 congruence classes in total in my cover. The idea of my paper is twofold. First, I introduce a way of picturing congruence classes as branches on a tree. Then I introduce a notation that reflects this graph theoretic property, and at the same time it allows one to write multiple congruence classes succinctly. Second, I use the Chinese remainder theorem to break congruence classes into their prime power components. And then, focusing on individual primes, I recombine this information in a way that reduces density computations. About a month later, after a lot of computation, I was able to construct a congruence class, or a covering system rather, with minimum modulus 40. I'd like to thank the Journal of Number Theory for this opportunity, and also the University of Iowa and the National Science Foundation for their support.